Welcome back. Let us continue our discussions on image morphology.
So let us take an example of a binary image and try to understand the terminologies that we have introduced in the previous video. Now here, as I mentioned, the coordinates of each of the pixel is specified by s x comma y. So here x and y are the coordinates. For example, if I take this as the corner 0 comma 0, this corner will have the coordinate as 3 comma 3. So the coordinate of this particular pixel will be 1 comma 2. So this is how we can represent the set. Now let me take a set A, and set A is all those pixels which are equal to 1. So the coordinates of this pixels are, as you can see, this pixel, the coordinate is 1 comma 1. This pixel, the coordinate is 1 comma 2. This is 2 comma 1, and this is 2 comma 2. So this is the set A, all those pixels whose gray level value is white. So white pixels are grouped as set A, and black pixels I can group them as set B. For example, this pixel, the coordinates is 0 comma 0. This pixel, the coordinate is 0 comma 1, so on. The last pixel here, the coordinate is 3 comma 3. So this is set B. I can define another set C, which comprises of this pixel and this pixel. So which is 1 comma 1 and 1 comma 2. So now we can try to understand all the terminologies that we have introduced in the previous class. For example, you can see here the set C, the elements 1 comma 1 and 1 comma 2 are also there in set A, 1 comma 1 and 1 comma 2. So which means the set C is a subset of A. So this is one of the terminology that we have introduced in the last video. You can also observe that intersection of A and B is a null set here. Because I have grouped all the pixels whose gray level value is 1 or as A, and all the pixels whose gray level value is 0 as set B. So obviously the intersection will be a null set. Now if I take union of A and B, it includes in fact all the pixels starting all the way from 0 comma 0 up to 3 comma 3. So like this. Now for example, if I try to do reflection of, or maybe we will try to do complement of A. So you know, in this case complement of A means, so I have taken A to be a set wherein all the pixels are 1, which means complement of A means all the pixels which are 0. So in this case it will be 0, 0, 0, 1, etc. So you will see that complement of A in this case is your set B, because that is how I defined set B. Set B, I defined it as all the pixels whose gray level value is 0. So obviously if this set is A, the remaining portion will be B. That is how I can define complement. So like this we can perform any operation. For example, if I want to do reflection, hope when we discussed about this concept, see, reflection, for example, reflection on B will be all the elements of B are multiplied with a minus sign. For example, if I take reflection of A, reflection of A like this. So all the elements of A are multiplied with minus sign. So that means it will be, the set will be like this. So minus 1, minus 1, minus 1, minus 2, minus 2, minus 1. That means the coordinates are multiplied with minus sign. This is reflection, which means, for example, if I take the reference and if you take this quadrant as first quadrant where the coordinates are assumed as positive, so minus 1, sorry, plus 1 comma plus 1 will be here. This value is plus 1 and this value is minus 1. It gets reflected, means the reflected version of this will be here, which will be at minus 1 and minus 1. So if this point, if I take it as A, the reflected version will be here, this point. So this is the meaning of reflection. Now if I perform translation, for example, if I perform translation of A by say some Z, this is a notation that we have used, translation of A by Z. So assume that I'll take Z is equal to say 2 comma 2. Then meaning of this is all the pixels are shifted by 2 comma 2. So for example, 1 comma 1 will go to 3 comma 3, 1 comma 2 will go to 3 comma 4, etc. So the new pixels will be 3 comma 3, 3 comma 4, 4 comma 3, 4 comma 4. This would be the new position. For example, this pixel will go to 3 comma 3, this pixel will go to 3 comma 4, this pixel will go to 4 comma 3, this pixel will go to 4 comma 4. So which means if I have a pixel at 1 comma 1, this is 1 comma 1, this is a positive axis. If I take this as a pixel A at 1 comma 1, this will now go to 3 comma 3. That means at this point. So this pixel is moved here to 3 comma 3. Like this all the pixels are shifted. So which means the original image is moved to new position now here. Originally it was here, So it is moved to a position like this. So this is the meaning of translation. Now let us try to understand few terminologies that we use in image morphology. That is, we use a term called structuring element, and we use some operations like fit, hit, miss. So let us try to understand this in terms of a picture. Now what is seen here is a structuring element. It's of size 4 cross 4. So you have a 4 cross 4 structuring element here. So just to differentiate between a white pixel and a dark pixel, you can notice here, for example, if I am marking all of them as dark like this, I can take such structural element like this. So that means I'll assume that all the pixels here are 1. That is why I am showing all of them as dark. Okay, so now let us take an image example like this. Now here all the dark pixels are treated as 1 and all the light pixels are treated as 0. That means all these are treated as 0 and all these are treated as 1. So this is taken as 1, all these are taken as 1. So if I have this type of image and this type of structuring element, okay, so maybe I can just write the image in terms of the values zeros and ones. So you can observe here this is an 8 cross 8 image. So let me write an 8 cross 8 image. This is an 8 cross 8 image. So if you notice the original picture here, all lighter pixels are zeros. So these are all zeros. They are all zeros. These are zeros. And these are ones. So this is 1, this is 1, this is 1. This is this is 1, 1, 1. Then these values are ones. These values are ones. These values are ones. The rest of them are zeros. These are all zeros. So this is the image under consideration now. All these are zeros. So the darker pixels are treated as 1 here. The lighter pixels are treated as 0 here. That is only an assumption just for our. So now when I apply this type of structuring element on an image like this, okay, so this image is a binary image and my structuring element is a square structuring element. Now we use three terms. One is called fit. So fit is when all the pixels on the structuring element cover on pixels in the image. So what I mean is all the pixels. So these are all the pixels. So all of them are 1. Now for example, if I put my structuring element somewhere here, So I'll put the structuring element here. So notice here that the original image, all of them are ones, and which means that all the pixels of the structuring element are overlapping with ones. All the pixels under the structuring element window will have one. For example, all these four are ones. Okay, so then we call that as a fit. Okay, so in this case A is a fit because all the pixels of the structuring element will actually cover on pixels in the image. Now a hit means if any one pixel, that means any on pixel in the structuring element covers an on pixel in the image. Only one of them, if one or more, of course, okay, then we call it as a hit. So in this case, just observe B. This particular pixel is covered by the structuring element. For example, if I just put my structuring element here, you can see that this value is 1 and the corresponding element here is 1. So one on pixel in the structuring element has covered an on pixel in the image. So that is why this we call it as a hit. So a fit means all the pixels should be covered, whereas a hit means any one of the pixel if it is covered, if it is a hit. And miss is when no pixel in the structuring element covers an on pixel. For example, if I just show a structuring element somewhere here, let me use a different color. So if I use a structuring element here, you can see that all the pixels are off here. That means all of them are 0. So no pixel in the structuring element is covering the pixels. So by using these ideas, we will be doing morphological image operations on the image. So the assumption here is given image is binary and we have taken a square structuring element. Now depending on the available gray level values in the image and the corresponding structuring element, we use three terms called hit, fit, where all on pixels in the structuring element are covering the on pixels in the image. On pixel here means 1, that's the meaning. Hit means any on pixel in the structuring element covers an on pixel in the image, that is a hit. Miss means no pixel in the structuring element covers an on pixel in the image. So in this case, this is a miss, this is a fit, and this is a hit. So we will be using these basic morphological operations while while using morphology for the image processing applications.